but I'm not alone here. I'm here with a little friend. This one is GraphQL. I'll talk today about him. And we are here tech people, but we couldn't arrange tech survey. So I would like to do, instead of Slido like we do or other tools, to do a small survey physically. I would really ask you to stand up, please. And I will come closer because I don't see, oh, and the lights, great. Thank you so much. Oh, now I stood up the arena, great. So please sit down, those who work now with GraphQL in their day-by-day life, daily projects. Oh, nice. I don't know what you will get from this presentation because it's basic. Who, please sit down now, who at least heard about GraphQL or used in previous projects? So I see 5 people for whom I created my presentation. Great. I will catch you then later in the lunch and ask you what you remembered about this presentation. Thank you so much for your warm-up. So what we will be talking about today. First of all, what is GraphQL? How actually it works, because usually we discuss about it from the client side, but what's behind it actually. What are the use cases when we should and we should not use the GraphQL in our projects? First of all, what is GraphQL? For those 5 people who don't know, so it's an open source query language. So it's like SQL for databases. It's a query language that expanded itself into a framework that creates possibility to request specific data that clients need and stitch it to the different data sources. It's not tied to specific data storage, so we could use any data storage that we can imagine that could be stitched through the different codes, languages. And also it provides us this flexibility. It's efficient data fetching because the client requests only the data that they need. For example, we could have a big object about the user, but for specific needs of the client, we need only 2 or 3 fields. So this is the flexibility that GraphQL gives us. We can query only those 3 fields, and in this way, we use less bandwidth, we use less resources. And it's a schema-based service, so this means that we can provide it to the client and describe what data do we have, what we actually support, what data types, especially when the client is not part of our ecosystem and we should expose to someone from exterior. This creates some clarity and also helps us to document everything. About Kafka, in the presentation about Kafka, you've heard about schema, so same benefits are here with the schema that is present in the GraphQL. What are the common use cases? So for those who are not developers, Roman asked me to describe what are the use cases and when we should think about at least GraphQL. So first of all, it's when we need a flexible data retrieval. As I mentioned, when we have a big object, we can retrieve some small amount of it. On the other hand, when we need a big description, that actually we need different parts of the data that is not provided for a single endpoint or for a single object, then we can retrieve that in a single request, and this gives us flexibility in the way that what exactly we are retrieving. So, for example, GitHub and Shopify uses this as a use case for their business. Also, one advantage that gives GraphQL and could be used for is fast iteration, especially for that cases when we develop different UI models and we do not want to change the backend for that. We only want to modify how the UI works for our client to maybe do some A/B testing. That is very popular way of developing products now. And in this case, we could have a GraphQL that retrieves some data in one case, some data in another case, and in this way to iterate faster. When we have multiple data sources. So I would be talking a bit about data sources later, but for example, if for one single page we need resources, data from different resources like database, other API, other service that is not even our service, for example, then GraphQL can stitch this all together and provide in a single request. Yeah, and sorry, I messed up. So this is this one, and the previous is about different data needs. Is when we have multiple clients. For example, we have mobile application and we have a web application. And in this case, usually the requirements for the layout, for the data that we have there, they're different. And GraphQL helps us to have one single backend request that serves both and allows users to, clients to use the data they need. So how does GraphQL work? So we have a client, an HTTP client, and GraphQL is working through HTTP. It serves a single endpoint that is, come here. That is accepting only one URL endpoint, and what we want to request we send as a body, and we send it to the GraphQL. It do the magic and serves us back another HTTP response as well with the body that contains the fields we've requested or the errors in case we couldn't respond with the data that were requested. We always serve the code 200, even in case we have errors. We serve other error code 4 or 500 only when we have errors in the network or on the server. So this is a thing that a bit complicates or can be used as advantage when we develop. So how does actually GraphQL works? What's the magic inside? First, as I mentioned, we send the request. And then we have as you see in the previous slide, we have a plain text that is written as a JSON. So we need to parse that JSON text, and we create an abstract syntax tree. This is needed for later processing. Then we have a schema that defines what fields do we have, what if it's a enum, what variants are admitted, and so on. So we do a schema validation. Then we have an execution preparation. We create a context with all the authorization, for example, or connections to the databases or other resources, some data about the context from which we requested the information. As well, we have variables that we send through the query, like we do, for example, in normal REST request. We do send I mean, in SQL request, we send variables when we prepare a statement, yeah? So we put the values in it. And as well, one of the technique to shorter the queries is to have fragments, like we deduplicate things and we have fragments. So in this step, we put this everything back and we create a big tree of all the information that we need for data retrieval and populating the fields. And then we came to the part where we actually do some work about getting the data. We go to the resolver and functions, and we go to the data sources, request the data, having all the context that we already provided, and then we come back with this data. We assemble back the information, like if we could get the response, we put the information that it needed. Sometimes it could be a compilation of the data, like we don't retrieve, but we calculate it for some formulas and so on. So we put everything this back and we serialize it to the JSON so that we can send it back to the mobile or to the client that requested the data. We have not that many components about which we care about when we are doing the development. We do care about them when we design the system, all of the steps from previous step. But we usually have in mind 3 parts. First of all is data model, like in any applications that we have and to develop, we have a data model. In this case, this is schema. The schema has queries that we can request. Yeah, we know about them. Mutations is queries that modify data. So like we have different verbs in REST. So all the verbs that modifies data, here are mutations. We have objects that are composed from simple data and also simple scalars. So this is a data model. We create it as some kind of schema in different languages. You can have different libraries that do this by themselves. For example, I am a Java developer, and there are different libraries that helps to do this schema directly in the code base, so you don't need to do a lot of work additional. So second one is a business logic. How do we retrieve those data? What exactly it represents? What we want to present to the user and how we want to get those data. And third one is a data source, so from where we serve those data. As I mentioned, those could be the databases, and usually they are. Those could be the microservices, and this is also a scenario, especially when we have very big system and we need to do some layering in order how to get access to the data, for example, for a user. So we don't want to expose everything what we have in our infrastructure, and we want to give access to the only some parts, and we don't want to expose our microservices to the clients. Of course, it could be some internal computations, as I said, that takes into consideration some environmental information or not environmental at all. Resolvers. Those are the keys that makes GraphQL useful and fast, because this is where developers come in place. So how we write resolvers mostly represents how we efficiently will get the data from our system and how fast it will be actually. What it is a resolver? It is a function that's responsible for fetching those data exactly from the data source, so having some business in mind. It has some properties. So first of all, we have a resolver that for sure delivers information about each of the fields. Like we describe how we get information for each of the fields from the schema. It has a hierarchical structure. So we usually, in our data, really there is no hierarchy in the data. So when we have a tree, so first we resolve the one layer and then the second layer, third, and so on. So we have a hierarchy here, and we should care about it because it's one of the problems, as well as I will talk about later, that the deeper the tree, the more problems with the execution we could have. And asynchronous operations, we can, if we have leaves that are parallel, we can have a parallel execution. We can have those promises, as in a lot of languages we do now have, that allows us not to run asynchronously and allow to deliver content later and have some substitutes for that for in our system in clients. Problems. I don't remember whom, but asked me, so when we read forums, usually it's about only good stuff, so what about bad stuff? Here it is, problems. First of all, it's the n+1 query problem. I think this is a problem for many other types of systems, especially if they're not thought about. But here it's a very pronounced problem because we usually we tried to separate each field, and if we don't think in advance how to mitigate this, this can really explode. For example, if we have different users and each of them has additional data, and when we try to collect all that, so we have a lot of queries to handle. And the second one is complex queries that requires a lot of different data, a lot of deep structure for one and one and one and one. And we had these situations. It's a very hard to navigate problem. Yeah. Of course, there are solutions. First solution is a data loader. It was developed already as a library for most of the languages. So this exactly answers the previous problems. It's a batching mechanism that allows us to do a micro-batching in order to collect that queries and do one single query to the database instead of a big number of queries. And also to be efficient in time. So we have a very small time period that allows us to not have very big latency in data. And also it has a caching in memory so that we prevent fetching again the data that we already have. Some additional caching strategies in GraphQL. I understood that most of you were yesterday at the presentation, so I've liked one of the statement, cache everything, from the presentation about the performance of the sports website. So same is in GraphQL. Actually, we try to cache wherever we can because it's expensive to use GraphQL queries, and we want to make everything faster. So one option is to cache at the client side, especially if it's mobile, for example. We have much more control of what we store and how we manage it. But as well on the browser as well. So we have special libraries designed for GraphQL that do caching on their own, but also like we are developers, we can cache by ourselves easily, and to not. So this is a choice to cache. And the server-side caching. So we have different types of caching. Ones are specific for GraphQL, and others are not that specific for GraphQL. They're general one. So first of all, to cache what we can if we have a data. The problem is, as you remember in the first slide of how GraphQL works, we have only a single endpoint. It's only one endpoint for our GraphQL. And in this case, it's hard to use caching mechanisms that we have for CDN, for example, and or proxy and so on. So we have to think about other algorithms for that. Or how we would do that. One of the ways is to cache the response based on the query. The query itself usually is hashed because it's expensive to have a query. We had in our project a query that was 40 megabytes. So imagine to get 40 megabytes each time to do all the parsing, to do all the variable substitution, validation, and so on. And a solution for this and to speed up things is to cache the query itself and only to substitute the variables. In this case, we have a hash of the query, and we send a hash of the query to the server instead of a whole query. If we can find it in our storage, then we do not do all those operations, and this simplifies the processing and speeds up the returning the data. If we have new variables, we would go back to the resolver, said resolve again. If we don't have different variables, then we already know the response what we should send. Field level caching is then we cache on the level of the resolvers, and this also speeds up the process. What are the don'ts when not to use GraphQL? So mainly from what I talked about, what are the use cases of GraphQL, others that are not. Maybe it's not a good idea to use as a source of the use case of the GraphQL. For example, applications with high traffic and a lot of data needs, because we cannot cache a lot of things, and performance for computation is really expensive. So if we have a high traffic, then we should think if the GraphQL is the right thing for us. If we have autonomous teams, each team would have its separate schema, and then we would need to do the schema stitching. So we would need to have a schema from everyone and to put all together to create a federation of those schemas. And this is possible to do, but this complicates the things, because we could have collisions, and we would need to think about how to mitigate those collisions, and this creates some burden. If we have limited resources or costs, it depends what are our limitations, but all the computations that we do for this flexibility of the GraphQL requires a lot of computation power, a lot of cache, as you've seen. So this means that if we have a limited amount of money or other kind of resources, then we would better consider other ways of getting the data. And simple ops. Like previous talks as well, people said that do as simple as possible, because this is the key. Like, do not overcomplicate things. If there is a new technology, it doesn't mean that it should be applied. And one of my final thoughts. It's hard to explain GraphQL in 30 minutes. Thank you.
Thank you for the presentation, Anastasia. So we have some questions from the audience, but let me pick a good one. I think I like this one. Did you run into a situation on a need to synchronize the client side and the server side Apollo cache? How did you deal with it?
Wait.
This one.
No, we didn't have such use cases. So I couldn't say from experience how we would do that.
Mm-hmm. And maybe let's try this one. Did you consider to replace queries to 40 megabytes data with subscriptions, which can return multiple smaller chunks of data with significantly less CPU memory usage?
Yeah, good question. These 40 megabytes gave us a bit of thought why we are in this situation like this. It's not a normal situation, but we wanted to do a server-driven UI, and in this case, the client sent us whatever it could render on their screen. It was a mobile application. Who works with mobile knows about things that you try to put whatever you can in the app in the hope that when you will need it, the client will have it already on your phone, and you won't stuck into the thing that the client don't want to update their application. So we put a lot of fields that we don't actually use in that time, but we wanted to send and to validate the request. But later we send the response, and the client just selects whatever he wants in order to display. So yeah, we try to mitigate that situation with smaller chunks. We tried to split information and to consider how we can simplify it. But it's a use case. It's one of the cases when the technology wasn't used exactly in the way it was supposed to be used. So we happened to be in this situation.